What's up, everyone? Welcome back. Patrick here. Moving on to the next example dealing with perfect square trinomials. So what we have to do in this video, we have to determine the value or values, sometimes there will be multiple values of m, so that each of these expressions here is a perfect square trinomial. So a fairly popular question that you'll probably see come up. And when we're dealing with a perfect square trinomial, we're dealing with that formula. We're going to be using that formula in this case. So when you're watching this video, I'm assuming that you've watched the previous videos where we factor perfect square trinomials, either with decomposition or with that formula that I'm about to write down. If you're watching this on YouTube, you could follow the videos in order. There's a link to the course in the description box. So the formula for a perfect square trinomial is a squared, and then this middle term can be plus or minus 2ab plus b squared. Right? If we have an expression or a trinomial in that format, we know it's a perfect square trinomial, meaning that it's going to factor into the same factors, either a plus or minus b squared. So if this is positive, this is going to be positive. If this is negative, that's going to be negative. Now in this particular video, we're not actually going to be factoring, so we're more so going to be working with this left side of the formula. And so what we want to do is we want to write these expressions here, and we just want to try to take this and relate it to this formula or rewrite this in this format. And then from there, we can potentially get a and b values and then solve for that unknown. So it's going to depend on where the m value really is. Notice that in these ones, it's going to be in the middle, but over here, it's going to be on the end. It's the b squared expression that we're going to be solving for. So it really depends. You got to kind of just like mix and match and see how you could take this, relate it to this formula in order to solve for your unknown. So from here, notice that we can get the a and the b value because we have the n values. The unknown is in the middle. So this x squared, it's already in this a squared format, which is nice. And then this 49, we can rewrite as 7 squared like that. And so we could tell that the a value in this expression, the a value is x, and then the b value is this 7 over here. And then we have this plus mx right here. Now this mx, it's equal to that portion right there. So there's actually going to be multiple solutions for this. So this mx, this middle portion, has to either equal positive 2ab or mx has to equal negative 2ab. Right? That's where the potential multiple solutions can come in because there's a plus or minus over here. And notice that we have the a value, we have the b value. So we could just take those, plug them in here into that general formula. So we'll have mx equals 2 times that a value of x times that b value of 7, like that. And we end up with mx equaling what's over here? 14x. And then notice mx equals 14x, the x's just cancel out. It's obvious to tell that the m value, one of the m values, is 14. So if this m value is 14, we're going to have a perfect square trinomial. And if you want, what you can do is you could take that m value, you could plug it in. I'll just leave this over here for now because there's going to be another m value. But again, if you want to, you could plug it in and see if it actually does factor into perfect square trinomial. So I'll check it for this one, but for the rest, I'm not going to be factoring. We're just going to be focusing on finding the m values. But for the other ones, if you do want to check your answer, if you do want to factor to see if it does indeed factor into a perfect square trinomial, please feel free to do so. So here, notice that a value is 1, right? This, by the way, this a value in the quadratic, it's different than the a value in the formulas, right? This is the decomposition method. So the A value here is 1, the B value is 14, the C value is 49. Let's split this off here. So what's the AC value? The AC value is 1 times 49. So are there two numbers that multiply to 49 and then add up to that B value? 14, 7, and 7, 7, and 7. So even right there, we could tell because both of those numbers are the same, it's going to be a perfect square trinomial. So we decompose that middle term. And then notice we could take out an x from the first two. We could take out a 7 from the next two. Then we could take out an x plus 7. What are we left with? X plus 7. And so that's going to be x plus 7 squared, which indeed is a perfect square trinomial. So if you do want to do a check, maybe if you're on a test, you have extra time, you can actually take your m value that you solve for, plug it in, and see if it does factor into the same two factors. Okay, so an m value, let's write it over here, of 14 is one potential, but as I mentioned, there's another potential because mx doesn't necessarily just have to equal positive 2ab, it could also be negative 2ab. Okay, and so we just follow the same process here. We know the a value is x, the b value was 7, so we end up with mx equaling negative 14x. Cancel those out. M is negative 14. So if this m value is negative 14, it would also be a perfect square trinomial. It would end up being x minus 7 squared. That's what it would factor to, right? So this is a case where there are multiple solutions for the m value. And that's pretty much it. That's the process, right? Again, sometimes it's going to be a little different because the m value might be on the ends, and we'll work with that as well. Here in this one, it's actually going to be in the middle again. So we got 9x squared plus mx plus 64. So same thing here. We want to rewrite the ends as a squared, something squared, and then b squared. So from here we could tell the a value is 3x, the b value is 8, like that, right? And then we have this plus mx over here. But we know that this middle term has to equal either positive 2ab or it has to equal negative 2ab. And then we could just take our a and b values, plug them in. So we'll have mx equals 2 times 3x times 8, which would give us 48x. Then we got mx. mx equals 48x. We could tell m is equal to 48. Or over here, we'll have mx equals negative 2 times the a value, 3x. It's basically the same thing. It's just there's going to be a negative in front. So we'd end up with mx equaling negative 48x. So the m value can be also negative 48. So if this m value is positive 48, or if it is negative 48, that would give us a perfect square trinomial. So that's going to be the solution over here. We'll have plus or minus 48. Moving on to part C. Here, where is the m value? It's in the middle again, but notice that there's a little bit more added over here. But it's not a big deal. Right? Don't let this all confuse you. Right here we have this 2m xy in the middle. But same thing, we have these n terms that are already defined, so we want to take those, let's rewrite them in this format. A value is 4x, the b value is 5y. And then we have this plus 2mxy, so plus 2mxy. So we know this middle term has to be in that format. So either 2mxy equals 2ab or 2mxy equals negative 2ab. Same exact process. And actually, notice what's nice, the 2's just cancel out here. So really, mxy has to equal ab. The the 2's cancel out, but we're still left with a negative 1 there, so mxy is equal to negative ab. You keep the 2's if you want, but because they're just on both sides, you could divide both sides by 2. That would get rid of the 2. So from here, this is where we're solving, so we're going to leave this side as is. What's the a value? 4x. What's the b value? 5y. What do we end up with? 20xy, mxy. We could just divide both sides by xy to get rid of those, so we could tell the m value is 20. Over here, same thing, mxy would be negative 1 times 4x times 5y, which would give us negative 20xy. M value is negative 20. And so those are the two solutions. So if we plugged in positive 20 here, we'd end up with 40xy in the middle. Or if we plugged in negative 20, we'd end up with negative 40xy in the middle. And either of those two is going to give us a perfect square trinomial. Moving on to part D. So this one here, it's going to be a little bit different because notice that where's the m value that we're solving for? It's going to be on the end here. But the same thing is going to apply here. So notice that this m, if we mix and match it, this m is basically going to equal this b squared, right? This m is equal to the b squared. Now notice here, this x squared is equal to the a squared, and so we could tell that the a value is just going to be x. And then this negative 12x, it's going to equal this middle term. Now it doesn't really matter whether we use positive 2ab. Let me show you why it doesn't matter, and then we'll go from there. You could use either positive 2ab or negative 2ab, because when you solve for that b value, it'll be a plus or minus, but then over here when you're going to square it, you're going to end up with a positive value for m. So in this case, the m, there's only going to be a positive solution, because remember, for a perfect square trinomial, this can't be negative. This is always going to be positive. You're always going to be squaring a number. So what you can do, what you first do is from here, you get this a value. We could tell that it's x. And then we plug in that a value over here. So we'll have 2 times x times b, which is negative 12x. So we'd end up with 2bx equals negative 12x, right? So we got 2bx equals negative 12x, so we could tell that 2b has to equal negative 12, or if we divide both sides by x. And so over here, divide both sides by 2, we know the b value has to equal negative 6. So we get a b value of negative 6, and then we'd end up with negative 6 squared, which would give us 36 for the m value. Okay, so the m value here would be 36. Now, what if we used negative 2ab? The negative 2ab case over here. We'd have negative 2x, then we'd have negative 2b, negative 2, negative 2, negative 2. We'd end up with a b value of positive 6, but then notice positive 6 squared would still give us that m value of 36. That's why I was saying it doesn't matter which one we use over here, whatever b value we get here, because we're going to square it, right? This n portion is b squared to get that m value. It's going to be positive 36 anyway. So for part D, there's only one solution. And again, you could test this. You could take x squared minus 12x plus 36. If you factor that with decomposition, you'd end up with x minus 6 squared. It would be a perfect square trinomial, right? So if this m value is on the ends here, or maybe over here, it takes a little bit more work, but it's still not too bad because we only get that a or b value. We don't get both. So then we have to plug that in here, and we have to solve for either, in this case, we have to solve for the b value. For part E, we're going to solve for the b value, but then in part F, we're going to solve for the a value. and then we just relate it to that part of the formula that we're looking for. Okay, so let's try part E. It's very similar. Let me erase all of this so we're not getting confused. So we got what? 121 x squared minus 132xy plus my squared. So same sort of deal. Here we're going to be dealing with multivariables, okay? But same thing applies. So here's where the unknown is going to be. So let's just leave that for now. And let's work with these two portions. So we know 121x squared, we could rewrite that as 11x squared. And so notice that the a value is for sure going to be 11x, like that. And then we have this minus 132xy in the middle. So we know that this middle portion, it's going to either equal 2ab or negative 2ab. Same sort of thing. It's not going to matter which one we use because we're going to end up squaring our values later anyway. But let's work with the negative. So we'll go negative 2ab has to equal negative 132xy. And then we could just get rid of the negatives. What we could actually do is we could divide both sides by negative 2 right now. So ab has to equal negative 132 divided by negative 2 would give us, what, 66 xy, like that. And we know the a value is 11x, so notice we'll have 11x times b is equal to 66xy. Divide both sides by 11x because we're solving for the b value. So the b value would be 66 divided by 11 would give us 6. The x's cancel out. We end up with 6y for the b value. Okay, and we know that from here, this b squared has to equal my squared, and we know the b value is 6y. So let's, first off, let me double check here. You know what, for this one, let's actually factor it at the end, just to make sure that our answer is going to be correct. We're dealing with multivariables, so it's a little bit more complex. I don't think it will hurt to test it out. So here we could tell this b squared has to equal this my squared. So what we could do, we could plug in this 6y that we know the b value is going to be, square that, that's going to equal, sorry, this should be my squared. 36y squared equals my squared. So notice those cancel out. The m value is 36. So that ends up being the final answer for this one. This m value would end up being 36. And as I mentioned, let's actually take this, plug it in, and test it out. Let's see if we actually end up factoring into a perfect square trinomial. So notice that the a value is 121. Notice the b value is negative 132. And then the c value is 36. And then the ac value, when you multiply these, is going to be 4,356, like that. So what two numbers multiply to 4,356 and then add up to negative 132? It's actually going to be negative 66, like that. And then we could decompose that middle portion, that b value, into those two values like that. From these two, what can we take out? We could take out an 11x and we'd be left with 11x minus 6y. Then from these two, we could take out a minus 6y. This is negative, so it's definitely going to be negative. 66, 36, we could take out a 6. There's a y to the 2, so lowest exponent would be y to the 1. And we'd be left with 11x minus 6y. Then we could take out an 11x minus 6y. What are we left with? 11x minus 6y, which is 11x minus 6y squared. So when this m value is 36 here, it indeed does factor into a perfect square trinomial. All right, so just a coincidence that both of these are actually the same, I just noticed. But that ends up being the solution. So we had to get the a value first here, which was 11x. Then we had to plug it into the negative 2ab. Negative 2ab was equal to negative 132xy. We solve for the b value, which ended up being 6y. And then 6y squared, b squared, has to equal this my squared. We end up with 36. Y squared equals my squared, so then we could tell that the m value would be 36, right? And then finally, part F, same sort of thing. Now we're going to be solving for that first term, but same process is going to apply over here. Okay, it's going to be a little different because we actually have an m squared over here, so I think this is actually going to give us a positive or minus, but let's follow the same steps. So again, we want to relate it to the general formula. So notice we could definitely solve for the b value because we could tell b squared equals 169 y to the 4. So b squared, we have to write this as something in brackets squared, which would be 13y squared. 13y squared squared would give us 169 y to the 4. So we could tell the b value is 13y squared. So let's actually write that right there. Okay, so from here we got our b value for that general formula. Now from here we could tell that this middle portion has to equal that. And we can use plus or minus. Let's use the, because this is positive, I'm just going to line it up. So we'll say positive 2ab in the formula, we know that that's going to equal 260x squared y squared, like that. Well, notice we already have our b value of 13y squared, so we could plug it in here. So we'll have 2a 13y squared, 260x squared y squared. 13y squared times 2 would give us 26 y squared. Let's separate these like that. We're solving for the a value, 260x squared y squared. Right? Then we could divide both sides. Divide both sides. These cancel out. What's the a value going to be? 260 divided by 26 would give us 10. The y squareds cancel out. We're left with x squared. So the a value in this formula is 10x squared. So one more time, we got the b value here. Then we took that b value, because we knew this and this have to be the same, we plugged it in here in order to solve for our a value. And now let's write our a value. So it's 10x squared. So that's the next step. And now that we have our a value, we know that this entire thing has to equal a squared. So a squared has to equal m squared x to the 4. Plug in this a value here. Okay, so like I said, it's kind of just mixing and matching. It's almost like solving a puzzle, just a bunch of pieces to go through. Now over here, this 10x squared squared, we take the 10 and we square it, which would give us 100. Then we have x squared squared, which would give us x to the 4. Then we have m squared x to the 4. The x to the 4's cancel out. And we're just left with m squared equaling 100. Right? Let's actually continue going in line here. I'm just worried that I'm running out of room. So we have 100 equals m squared. To get the m by itself, square root both sides. So notice the m value can be plus or minus 10. So that's going to be the answer here. Because whether it's plus or minus 10, positive 10 squared, we're going to end up with 100x to the 4. Or if we plug in negative 10 for m, negative 10 squared would give us that positive 100 here anyway. And so if this is 100, x to the 4, that's the first term, then this entire thing would end up being, this expression would end up being a perfect square trinomial. I think what it would factor to would be 10x squared plus 13y squared. Right, if you actually did decomposition on that, you'd end up factoring into those two factors, 10x squared plus 13y squared. So there's going to be two of them that are multiplying. That's not what the question is asking for. They were asking for what m value here would make this a perfect square trinomial. Well, the m value would be plus or minus 10, because plus or minus 10 squared would give us that positive 100.